Okay, just a quick video today to introduce you to an interesting area of metaphysics. Today I want to talk about the metaphysics of time. Let me just go to the to the presentation real quick here. Get that up. Oopsie, too good. There we go. Okay, so yes, the metaphysics of time. Now, so what do I want to do today? Because again, this is a brief introduction. So I'm going to do, I think I'm going to do three things. I'm going to show you part of the way that, I'm going to show you some of the ways that philosophers conceptualize thinking about time, sort of what the a really rough outline of sort of what of some of the professional discussion of the metaphysics of time is. Then the second thing I want to do is I'm going to try and explain why philosophers have some of the views on time that they do, because one of the two basic ways that philosophers talk about time is in a very sort of strange way, a very counterintuitive way. So part of my project here, and again in a short introductory context, is to try and show you why it is that anybody might be developing a strange view like that. We were talking about a philosopher named Berkeley a while back, and I think that was another example of a philosopher where people think, well, why on earth would he be saying such a thing if it's not in the right kind of historical context? And I think there's a similar issue with the philosophy of time, with the metaphysics of time. You sort of wonder, well, why would someone be working out that sort of idea? And then finally, the last thing that I want to do today is show you some of my own thoughts. I have some basic orientations. As you know, I'm an empiricist. Roughly, that means that I am sympathetic to arguments from experience and the quality of experience, and not so sympathetic from arguments that appeal to other kinds of issues, and particularly speculative things. Anyway, let's get on with it. What I want to explain here, you hear about this A theory and B theory. Now, A theory and B theory, I don't think these terms have done us very much good. There was a philosopher just about 100 years ago, the turn of the last century, named McTaggart, and he published some articles that are very famous and kind of defined a lot of discussion of the metaphysics of time since then, using these terms A theory and B theory. I'm not that into the terms A theory and B theory, but I'm going to explain them to you because I do want to give a fairly good analysis of B theory. That's the view that I was explaining a moment ago. Looks like it's weird, and it is weird, and I want to explain to you why anyone would think about that. Looking at the first bullet point here on our slide, then, A theory being more, plan A, our ordinary experience of time. Specifically or technically, what does that mean? That means that we think that time is moving. I really want to think hard about this notion of the motion of time today. I think that's a really important issue in the philosophy of time. And it means that we think that that's the way you sort of index objects and events. They're in the future, or they're in the present, or they're in the past. Once they're in the past, they're receding farther and farther into the past. And it does seem as if things are sort of approaching from the future. Although, as I say, one question here is the world sort of, is time sort of passing over us and our world, or are we sort of passing through time? So you have this kind of concept of something's passing. There's some kind of motion. I say that it's the motion of change, and it's really the concepts of changing and events that are the key ontological concepts to understanding the metaphysics of time. So anyway, that still on that first bullet point, then motion essential to the phenomenology of time, the experience of time, the way we describe time when we're trying to talk about it. We're trying to talk about that flow. And again, then technically that means that you say that there are things in the future, supposedly, or there are things in the, or at least that there are some things in the present, and then those things that are in the present recede into the past, they move into the past. Okay, so that's our, our sort of ordinary phenomenology of time. So what's B theory then? B theory is a kind of God's eye picture of time. As I say there in the second bullet point, it's a thought experiment. What's going on? One thing that's going on there is that we're taking the idea that time is a dimension seriously. We're going to get to the unity of space-time in a moment, but let's just use our common sense, quotidian way of talking, and we're going to say there's space, like the space in the room, and there's time, like the time that's going by right now. And so the idea here is think about a God's eye view in the sense of think of God as not in time. So the whole universe is happening in one big moment. So looking down on, say, a two-dimensional surface, right? And then the beginning of time would be, say, to the left, and the end of time, if there was one, to the right. But in any event, there's nothing flowing here. That is, if time is a dimension like space is a dimension, then I'm here and the file cabinet's on the other side of the room, and I'm now, and some other, and me making this video is right now, and some other event is 3 years in the future or 3 years in the past, just farther away in the dimension of time. So again, in that sense, there's no change. And looking at that last bullet point on the slide, so the second bullet point first, let me finish that up, I'm sorry. So A theory, you've got everything's indexed, it's either the future, the present, or the past, right? And everything is located in time in one of those categories, and the future is moving towards us and the past moving away, or the present moment is moving along, or something like that. It's difficult to talk about. Okay, then on the B theory, then everything is indexed to a particular time. That is, you have, say, Tuesday, May 11th, 2021, but that has no greater or lesser ontological status than Monday, September 7th, 1846, right? I mean, you're indexed to some particular point on the timeline, which is conventional, of course, but that's the only way things are indexed. So again, the B theory sort of ignores our ordinary phenomenological experience of time, which is that the future hasn't happened yet, maybe doesn't exist at all. Maybe we're sort of on the edge of the wave or something. Then there's the present right now, which feels very real. And then there's the past, which I can regard as something that has occurred, but which is here no longer. My childhood dog exists in the past, but not any longer. So in that sense, tenseless. No present, past, or future, just only different points along this God's eye perspective temporal plane, right? Now, so of course that, and that's the B theory. That's what the B theory is, that time is actually another dimension, which means that it can be represented sort of simultaneously, all points of it occurring simultaneously, an untensed theory of time, whereas the A theory is the tensed theory of time. Everything's either tensed to the future, the present, or the past, which brings up the question, why the B theory? Because that's a really weird way of looking at things, isn't it? Well, there's a couple different reasons why. And remember, too, that physical scientists sometimes tell us that things aren't the way that they appear. And they're not saying something really very hocus pocus there. They're just saying that on another way of describing things, say the physicist might tell us that ordinary objects are mostly empty space. Now, we don't experience them that way. But that doesn't mean the physicist is wrong. They're just making a certain kind of point, trying to communicate a certain kind of information. So maybe if physicists or maybe somebody else is looking at time, they might want to make a similar kind of point, which is, maybe a valid point. Maybe it helps when the physicist tells me that the physical objects are mostly empty space. And maybe something similar could be said about time. Maybe the B theory is an example of something like that. But we do want to know why it is that someone would want to model time in a tenseless way. Usually, one thing is you want to show that it's you want to have a naturalistic ontology, a materialistic ontology. So the ancient Greeks, for example, a whole lot of the theory, I'll even step out of this just for a second with the ancient Greeks, because a whole lot of ancient Greek physics, it's really interesting stuff. One of the reasons ancient Greek physics is so interesting is because they don't have the logic and the physics sorted out at all. And sometimes they say things that seem to us very strange. But so, for example, if you thought that a physics, and these are arguments that are still around today amongst ontologists in one form or another, but say you thought that a physical object was really made out of all the properties that you would use, say, to describe it. And so that your theory of a physical object was that it was maybe a bundle of properties. So if you're Plato and you think, say, universals are fundamental reality, right? Then and properties are universals, then that's sort of systematic a little bit there, maybe. So, but on that view, then, if you took a property away or added a property to the bundle, since your theory literally is that a physical thing is a bundle of properties, then that means it's not the same thing. On that theory, then a physical object does not maintain its identity when it changes. You see, the Greeks are wanting to know how come what gets this energy in the system? What are these changes? Why are these changes happening? Same kinds of questions that we have now. And so, I mean, you might also think that, then could have other theories of physical objects. But on this B theory, you see, and I guess I'll just go back to the slide. On this B theory, you're a kind of, you're not changing at all. There isn't any change happening. And we'll talk about that more in the next slide. Another reason is nominalism is the third bullet point. So the nominalist wants to show that it's a metaphysical project. They want to show that the only thing that exists are physical objects, particular physical objects. That the universe is made out of particular physical objects and that's all there is. So everything else that you talk about has to be somehow analyzable or translatable into the language of physical objects. And that's going to be important for a number of metaphysical topics that we look at. It's going to be important when we look at the metaphysics of modal logic, for example, which is a really interesting area of metaphysics. So, how does B theory do that for a nominalist? Well, you say there's space and there's time. The B theorist wants to say all there are physical objects. The B theorist can say, what you're calling what you're calling the universe, first of all, and actually I think this is sort of right. What you're calling the universe is all the objects and events, all the objects that are present, all the events that are occurring. That just is what the universe is. Okay, so then on that view, you say, well, what is a region of space? Well, it's a set of physical objects. What is a region of time? It's a set of physical objects and events. Okay, everything is a set of physical objects and events. So that's sort of why the B theorists, and some metaphysicists, some ontologists who are trying to be naturalists are going to use the B theory as an example of saying, well, I can do what my theory says I should be able to do, which is sort of a big way that metaphysics kind of moves forward. Can we find an exception or a problem or not? Okay. So the B theory. Now, the other basic distinction besides A theory and B theory, as I say, let's review that again. A theory, just ordinary phenomenological experience of time passing and indexed to the future, the present, or the past. And B theory, a kind of God's eye view where you're looking at time as a complete and fixed dimension, such that there isn't any motion or change happening in your perspective on time at all, which is weird, but that's what B theory is. The other distinction that's been around for a very long time is absolute time versus relational time. By now, also, I hope that everyone's noticing, I certainly noticed this, that our intuitions about time are strange and don't do us a lot of good. We're really not used to thinking about time in some of the ways that we would need to think about it to understand it better. So absolute space and time, I would describe it as a sort of naive, maybe I'm wrong, picture of time. It's a very classical picture of time and space Let's do absolute space first because it's easier to understand. Absolute space then would be that there is all the space. It's just there. It doesn't depend on anything being in it. Absolute then in the sense that it is unchanging, such that the coordinates, the spatial coordinates, or for us, the spatiotemporal coordinates, are fixed. They're just there. There's a grid, say, a three-dimensional or four-dimensional grid that's just there in place, whether there's anything in it or not. Okay, and that's the absolute sense of time. So, for example, if we think about creation, and by the way, creation is a funny thing because we don't really need to think that there ever was a moment of creation. But we skirt along the edges of some of that here. I'm going to try and see if I can contain that discussion. It's going to get around to the idea that physical science deals with physical interactions between physical things. So you're just not going to get any kind of physical story about how something ever came from nothing. I think really there are sort of Cartesian and creationist systematic distortions that cause us to think about creation ex nihilo by God, rather than just to think about the modal status of the universe, which I would say is probably contingent. But that's the story that I'm trying to keep out of this and talk about this. So the last bullet point is really important because most people nowadays, both most philosophers and most scientists, have very much a relational view of time. Einstein, of course, had a relational view of time and space. As David Lewis, the very good philosopher, said in his book On the Plurality of Worlds, he says, the universe is not like the bottle that holds the beer. It's not an empty universe. The universe just is everything that's in the universe. Once we've got this idea of a universe, then our imagination can do things like represent empty universes, that is, infinite amounts of space and time with nothing in them. But I would say that David Hume sort of explains how we can do that by virtue of sort of combining things that we've experienced. Okay. Aristotle is really good on space and time. Remember all of the gang back in his day, the Ionian physicists and Democritus, the atomist, and Heraclitus and all the rest, were interested in primary being, earth, air, fire, and water, and of course the atoms themselves. Aristotle was tangling with these people in a very interesting way. And Aristotle's attitude, and he is a biologist at heart, and Aristotle's attitude is, look, you start with the world. We've got the world. And whatever knowledge we're going to produce it from the starting point of the world. And Aristotle says this is real important. Aristotle says, look, you can describe the organ of a body physically all you want, but until you describe it functionally, until you tell me what it is that this organ does for the larger organism, you don't know what it is. And so Aristotle's point about description and explanation is that oftentimes we understand the part in virtue of its function in the whole. This is what's called Aristotle's teleology, its functional role. And that is something that can only be understood in the larger context. So Aristotle then has a sort of credo, if you will, of working from the whole and seeing how the part fits into the whole, rather than trying to take things apart down to basic units like the atomists. So once you have a surface, this is the way Aristotle roughly sort of goes, the continuum. Once you have a surface, then you have coordinates in relation to the surface. And once you have that space, actually he calls it a place. And these places are constitutive of space. And then you have coordinates. And then you can have something in one place and go to another place. You can have movement. So there isn't any such thing as space and time. What there are surfaces and events. Physical objects, the physical universe, has a surface and events occurring. I'll get back to this event idea too in a minute or two. And that's really what quote space unquote and quote time unquote are. They're just our conventional measurements of surfaces and the lapsing of events. I think there's something really deeply right about this. And by the way, this also is something which Einstein is very, very congenial to Aristotle's view. Not a lot of daylight between them on this. Einstein and space-time. We've been talking about time and space, the metaphysics of time. Well, one of the first things you want to say nowadays is, well, isn't there space-time? It's neither time nor space, but the two things are one. And we find that in Einstein's theory of relativity. How well do we have to understand Einstein's theory of relativity? Well, actually, he didn't think we needed to understand it that well. What we did need to understand about it, though, is that both locations and velocities are kind of established in terms of their relationship to other locations and velocities. Okay, absolute models of time involve us in these logical difficulties. If time is absolute, then there's our local universal time, but is there some meta time, the time that was ticking by before the universe existed, maybe? What if the universe was 15 minutes this way or 15 minutes that way? Could it be that way? Why was the universe created, or why did the universe begin at that time? Or could it have begun at a time if time did not exist? And could the and how fast does time go? What's the speed of time? And so on. And as you can see, again, a lot of those are problems that arise from thinking of space as absolute, of space and time as absolute. Remember also on the Big Bang Theory, again, without trying to get into too much science here, but basically the theory is about 14 years ago, there was a state of infinite density such that there was no space and time. Okay, because the singularity, as it's called, is a state of infinite density, immeasurable. Okay, bullet point number 3, again, a little bit, look, space-time is relative, is all I want to say. I do put in there another point that it's body relative. People get that wrong, because the way Einstein thought was to imagine himself like riding on a beam of light or being in a train with another train passing by. This was just, the way he visualized things was from the point of view of an observer. But for a body in a location moving at a certain velocity, another body in another location, another velocity, is going to be at the location velocity it is relative to the location velocity of the body, the first body, all right? I throw that complication in there just because otherwise people have these Cartesian ideas that I'm very much against. And finally, the last bullet point, that space, can you imagine time without space? Can you imagine space without time? I'm not sure. I think it's really hard to imagine these things. And it's also really interesting to try and think about nothingness, which I think is interesting because most concepts work by representing. Okay. Very philosophical topic. Almost done. We're just out here shagging flies looking at, we have covered A theory and B theory and absolute time and relative time. And I think if you understand A theory and B theory and absolute versus relative theories of time, and see that the A theory is the common sense phenomenology of time, right, and that relative theories of time and space are what prevail in our community, philosophical and scientific community, then you're pretty good. Now let's look finally, and I have, I think, 2 more slides, at presentism. The alternative to presentism is eternalism, but we don't need to worry about that. Presentism, the view that only the present moment exists, and only the objects in the present moment exists. And of course, that also then those objects are wholly and fully present here in this moment. It's a very common sense view. I was talking to my teenage daughter a couple days ago thinking about this stuff, and she started to riff on her common sense view of things, and she was giving a presentist line, only the present exists. Those objects off in the future and those objects off in the past are not here, and thinking they don't exist. She and presentists in general are respecting this common sense phenomenology of the A theory. And I think what the A theory does deal with, both that sense of movement, that change is occurring, and the change is just constitutive of movement. Movement is change after all. that it's happening. And furthermore, this very important point that as things move into the past, they're gone, right? They move into the past, cease to exist, fade out, recede. The earth changes, the old things disintegrate. So those are basic facts. The irrevocable, the sort of what should we call it? The sort of existential law of the past. You move into something moves into the past and it's gone. That and the even more basic phenomenological fact of the movement of time and our experience of time. And presentism captures both of those very well. Presentism is not without intuitive appeal. And in a second, the last slide, I'm going to tell you about what I think. But anyway, in any event, I do think the third bullet point is right, that there's something wrong with the presentists insisting that things only exist now, in the present moment, because even existing now is to exist indexed to this moment. Well, it does exist right now. As I say here, more nebulae will exist in the future. Caesar did exist 2,000 years ago. It just looks like everything is always indexed to a time of sort of no matter what. So then, as I say there, what is the justification for giving the present moment some sort of privileged ontological status? There isn't any logical reason, and there actually isn't any scientific reason either. Intuitively, phenomenologically, it seems like sort of here we are in the present. Although even that is a weird thing to say, because the present isn't fixed at all. It's just, it's a flow. Now, there's another genre of theories, block universe theories, the growing universe theory, that says things coming into existence are adding to the total number of things that exist in the universe. So the universe sort of growing, that's at the edge of it. But again, that's dealing with this intuition that the future sort of doesn't exist. It's a little bit better than saying that the past also doesn't exist at all. Well, let's talk about time travel. Right, time travel seems to be an area, one of these areas like the mind-body problem, for example, where it does look like there are still sort of logical issues and conceptual issues which matter and which might help to sort of move things forward, including on the scientific front. I don't make that claim for a lot of areas for philosophy, but talking about time seems to be one of them. Well, first of all, notice that if presentism is true, then time travel is impossible. It doesn't mean that presentism is right or wrong. It only means that if you're actually going to say that literally you think the only thing that exists is the present moment, then time travel ipso facto is just impossible, because there's nowhere to go to. The only moment that exists is now. So there are no other times, and that's why there's no time travel. What about this one? Again, I don't claim to know what to think about all these examples. I'm just showing you what people think about here. Okay, if you could go back in time, then it looks like you could say, kill your grandfather, morbid enough. You could kill your grandfather before your father was conceived. There's a really good Family Guy episode about this. But that looks logically impossible. It doesn't look like that's possible, because it looks like you wouldn't exist if your grandfather had been killed before your father was conceived. Just looks like you just wouldn't be here. So what does that prove? I mean, does it prove a physical point? Does it prove a logical point? Or if it proves a logical point, doesn't that have some sort of significance for real experience? And can scientific points change our sense of logical points? I'd say yes. Speaking of that Family Guy episode, backwards causation. So someone shows up from the future and hands me a plans for a time machine. Of course, he's got one. He just came from the future in his time machine, and he gives me the plans for the time machine. Oh, great. So I build the time machine and it works. I invented the time machine. I go to the future and they want to know, how do I invent the time machine? Well, someone from the future came with the plans and so on, right? Now, it looks like that's possible, but it looks like that would be a closed causal loop. possible? Is it logically possible? It's like killing your grandfather before your father's conceived. What does this mean in terms of time travel? I really don't know, but I'm a little bit skeptical of presentism. But that just brings me, I guess, to my conclusion. Yeah, again, I'm not someone with a super well evolved theory of time, ontology of time. But I do suspect that what the universe is an event. It's an event, not a thing. It's not static. The universe itself is an event. And maybe if we look at the metaphysical, the philosophical metaphysical literature on events, maybe then thinking of the universe as an event, maybe that might be something worthwhile. I'd like to do that when I have a moment. So again, like Aristotle and Einstein, then it looks like time is a function of the unfolding of the event. If the universe is an event, then you're going to have the sense of time because everything's constantly changing. That's what an event is. And maybe now here's something that I'm wondering about: the first bullet point versus the second bullet point on this slide. So on the one hand, I kind of think it looks like the right way to say what the universe is to say that it's an event. It's an event of some kind. Calling things objects is kind of probably misleading in general in terms of really the physics of things. It's an event. And then I say perhaps an event ontology, perhaps thinking of the universe as an event, can account for the non-existence of the future. Because if the universe is an event, then you do have that front edge of the event, right? The event is occurring. And notice on an Aristotelian view, there isn't any time past that. So that also would be a further reason for saying, okay, this accounts for the absence of the future. But I come to that thinking about it. Really, I'm drawn to bullet point number 2 on this slide, though, which it does seem strange to me for people to say that the future doesn't exist. Phenomenologically, maybe, I guess it doesn't exist. I'm not sure what I think about this. It does look to me as if we certainly are planning for the future. I'm certainly planning on going and picking up my wife at noon. I think that's going to happen. And in between now and then, I'm going to post this video, So, and it does look, as far as I can tell, that physics, of course, think of space-time. We were talking about Einstein's notion of space-time. On that view, it does look also that, there's obviously the assumption is that the future exists. And as I mentioned before, I don't really see much of an argument for saying if you think you know what the past is like because you used to be there and you're here in the present, so you know what it's like. Then it seems like maybe you know what it's like to be in the future. Those are the kinds of arguments that David Lewis gives you. How about this third bullet point? I'm not sure. I'm going to float this up there. I don't know if this is a good argument or not, folks. Let me, that was kind of cool. What button did I hit? Anyway, the present moment, is this right? This is coming from sort of Einsteinian thinking. The present moment, after all, so the presentist thinks that only the present moment exists, but isn't it true that the present moment is defined relationally? Have I unpacked what that means enough? Maybe not, but the present moment is defined relationally and therefore it can't be by definition then, right? The only existing coordinate. If the coordinate only exists, remember the coordinate only exists relative to some other coordinate on Einstein, relative to a surface on Aristotle. They're both saying the same thing. Matter and motion is constitutive of time. Remember, on these views, there isn't anything really that's time. There's the matter and motion. There's the matter and energy, right? So the space-time itself is only coherent if there's matter in it, right? I think that's right. So that means then there's always going to be multiple movements, or at least put it this way, when you even use the word time, there's going to be time until there isn't any more matter in motion. There isn't any more energy, okay? Because that's just what time is. That's all time is. So that makes it a lot sort of less weird sounding, because what you're talking about is, well, it's over when there's no more movement, no more energy, no more change. The last thing I'm going to throw out there. So I think that argument, that bullet point 3, I'm sure other people have made it if it's good. I'm sure it's been made before. The last one, another one of my things I say when I can, because, and this is an empiricist thing to say, the B theorist says, look, it seems as if I'm certain that time is passing. I feel a little less certain when I try and think about exactly what I mean when I say that time is passing. Is that metaphorical or literal or what? What's passing? Am I passing? Is time passing? And so on, right? But phenomenally, in terms of the quality of the experience, it seems as if time is passing. And the B theorist tells me that time is not passing. Now, I mentioned the possibility that maybe that there's some sense of that remark, like when the physicist tells me that the solid object is mostly space. Maybe it works like that. I don't know how it works like that, but it could. But otherwise, it looks like it's an example of philosophical skepticism, like telling me that I don't know that the external world exists, or I don't know that there are other minds. It seems like I just do know that time is passing, right? And then the reason for mentioning that at all is that if that's true, then there are approaches to skepticism, just any skepticism. And if we can identify a claim as a skeptical claim, then we can take some of those approaches that we have towards skeptical claims in general and use them to approach that claim. And I think we can do that with the B theory a little bit too. I think it's skeptical. And I think we can overcome skepticism with some arguments from language. Okay, so, alrighty, so again, just a basic introduction to metaphysics of time, A theory, time's passing, an index to future, present, past. B theory, there is no passage of time, there is no movement of time. There are just all the different coordinates in a kind of space, like a space, like a floor. Okay. Then I talked about some of the reasons why somebody might think of a weird thing like B theory. And then we talked about absolute theories of space and time versus relative space and time. The fact that nowadays most people, including myself, accept a kind of relative theory of space and time. What do I know? But I do. And finally, just raised some other issues, talked a little bit about time travel, which I think is a fun part of the literature on the metaphysics of time. So as I say, a basic introduction, and one that I hope will also help to plug the issue of the metaphysics of time into some of the other issues about materialism and empiricism and so on. Okay, thanks. And I'll try to get you some good links. There's some very, very excellent links on this indeed. And I'll talk to you soon. Bye-bye.